No objections, just so the folks that can't be there. And we have a Samsung phone. I believe that is K9TEA. And we also have Neil, N9NL. Thanks for joining us, Neil.
No, it's KD9YDD on the Samsung.
Oh,
I didn't
YDD.
say.
Okay. All right, man, I was off on that one.
Yeah, I'm
All
gonna mute
right.
myself. I'll be listening and watching.
Copy that. All right.
Maybe.
That's top two. Sure. All right. So can you guys see my LibreOffice, hopefully?
Yeah, we
Yes.
can see it.
Okay, cool. Let's make this full screen. Stop first. Well, it gives me this one. Whatever. All right, I'm gonna wait maybe another minute and then we'll go ahead and start.
Wait for me.
Oh, you gonna get in on it too? Well, you might want to put your headphones on so you don't create feedback. All right, I think I'm going to start. We are recording this just so everyone knows. All right, well, I'd like to say thank you for everyone that's here, both people that are affiliated with Chicago FM Club and those that are not. My name is Nathan. The call is N9BBM. Most of you know me by the guy that works at CBS. So we started this, I'm the education coordinator. So we started this about a month ago. When Kevin and I started a Southside Club, we started this series and it worked really well there. So today's presentation is just another part of the series. If there's something that you would like to individually challenge me in learning and teaching, you can always find my information online or on Discord if you're a club member. Or if you'd like to present, several people have approached me about that. That opportunity still exists, whether it be at a general meeting or actually, online. So looks like Petra just joined. All right. So today's conversation is AREDN, AREDN, and let's go ahead and start. If you do have questions or comments, I'd ask you for this presentation, a little more formal, ping me at the end of it. So here are the things that we're going to discuss. The history of AREDN, the uses, and the best practices. So what is it? What is it? It's Amateur Radio Emergency Data Network. The primary goal of AREDN is to empower all of us, licensed amateur radio operators, to easily and quickly deploy a high data speed data network when and where they're needed. Now, the when and where are other good questions of what it is. It's a mesh network. So I just grabbed some call signs from previous ham radio operators that I know and then current ones. But essentially, it is a mesh. So you can lose any part of the mesh and it still exists and communicates. So what can it do? We can use it for emergency communications. We can cover large areas. In the metropolitan area of Chicago, we all know how big it is. So that's one thing that we can actually provide real-time data for emergency operation centers, police, fire, hospitals, medical transports, ARES, Red Cross, and of course, community emergency response training. So Think of it as a way to provide a service that might not be there full time. But when the big disaster happens, like the flooding in North Carolina or the flooding in Houston, Texas right now, where we can easily deploy most of our gear and provide another way for us to pass traffic and handle that. It started in Austin, Texas, of all places, in San Diego, California, in 2015. That's the gist of the history. It's been created and developed by the BBHN development team. So there's firmware updates. Hey, Mark, there's additional services, additional radios, and accessories. So it's growing, and it's actually still growing. It's not. I wouldn't even call it prime time yet. It's well established. So why do we need it? We can provide additional communication resources through the mesh network. We can provide real-time information and data. Phone service. You can actually do VoIP from your phone if you're if you create a network that bridges to this. You can provide security cameras. So instead of doing amateur fast scan television, we know how that all works, like the NTSC days, or slow scan television, which could take a minute and a half to send, of just one still frame. We can do this in real time in a much faster way. Photos of a disaster area, or we can also use it to actually link digital repeaters. So imagine right now with an analog repeater, you can have multiple receive sites across the city of Chicago. So they're listening to the input of the repeater, right? And then what they're doing is they're doing a crossband and sending that signal back to the transmitter location, the primary repeater site. And there's something called a voder. And what the voder does is it looks at all the receive sites and analyzes the signal to noise ratio. And as you're driving, when you go from site to site to site, the voter has to decide which receive site you have the best signal, and it votes you in, and that's what grabs that. Sounds pretty easy, but in reality, it's more complicated, right? Since you have to do crossband repeating and you have all these auxiliary frequencies that the FCC says you have to use. When you go digital, it makes it much, much easier. So let's talk about the evolutions of emergency communication, because I think that's what AREDN really works well. We went from old school paper, RF voice comms, and often transcribed by hand. And I'll tell you right now, no one wants to read my shitty chicken scratch. You probably can't read that. So can you imagine trying to pass notes around an emergency operations center and you can't read a person's handwriting? So then we went to digital RF, which would be packet radio, right? 9600 baud rate, so on and so forth. We can use WinLink for email, but it's better, but it's still not the best. And then you have AREDN, which allows you high-speed, multi-megabit, multi-bandwidth images, video, voice, internet-style applications. So at the TV station, and most of you Skywarn people, that's not me, you probably have a program called Slack where you can monitor what the National Weather Service does in real time. Can you imagine if you were to integrate a Slack program into your laptop, your tablet, or your cell phone? That could actually provide you quicker communication. Plus, you don't have to worry about someone's chicken scratch like the old school way. Oh, I went too far. Let me go back. So this shows you the map, and I have links in this presentation in case you want. This shows you what the mesh network looks like as of last Saturday when I created this presentation. It also shows you the bands which we'll discuss that are available. Most of the stuff is on 5 gigahertz. Okay, so there's 3 bands: 900 megahertz. Actually, I think there's 4, but I'll discuss that. But this shows you the current map here in the U.S. This is what Illinois looks like here. I kind of look down. I'm from Evansville, so you kind of can see what Illinois looks like. I was really surprised to see more data in the Quad Cities than say St. Louis or Chicago. So this kind of gives you an idea of what the current look and feel for AREDN looks like in Illinois. Chicago Metro is here. So we have four basic bands: 900 megahertz, 2.4, 3.4, and 5 gigahertz. You can tell by the map here that we have way more nodes on 5 gig than we do any other one. 2.4 is the second. So the most interesting piece about most of these old radios that you can use, they're basically wireless routers with hacked firmware, is most of them are going to be on 5.8. 5.4, excuse me, or 2.4 gigahertz, like what you have in your house now. So let's talk about the general requirements. It's a commercial radio that you can do COTS, commercial off-the-shelf radio that runs on OpenWRT. So any nerds out there and geeks like me, you've probably used OpenWRT. These are the four manufacturers, and of course you want the antennas to match your radio frequency. You don't want to use, 2.4 gig on a 5.8 gig radio, something like that. They also, everything I've read, if you're going to use it for emergency communications, you probably want to provide some type of emergency or auxiliary power. In the case of a transmitter for a TV station, we have a backup generator. So you could do power there. All right, so here's the frequency band plan: 900, 2.4, 3.4, and 5.8. Sorry, I said 5.4 earlier. So it is 5.8. It's important to remember that some of these frequencies are still shared with the consumer-based band plan, and that's covered under FCC Part 15 rules. If you look at a lot of your radios and different things that require RF, you'll notice on the back, if you take the battery off, it'll actually tell you this complies with the FCC Part 15. So they are required. Part 15 basically states, we're Part 97, by the way, with amateur radio, that they have to accept QRM or RFI, radio frequency interference. So the distance that people usually ask are, what's the distance out of all this stuff? And it can be anywhere from a quarter mile to 30 miles. And it's definitely line of sight. So if I'm sitting here away from the TV station 3 blocks away and I want to put up a 5.8 gig microwave dish, think of something like a DirecTV dish, like KA band, right? And I point that directly at the TV station, I'm going to have to see line of sight. If I don't, it's not going to work. So here's the frequency band plan. It shows you what the center channel frequencies are, and they have a channel number which is just generic. Like I said, I can send this out to you so you can actually see it. And it also shows you what's shared with licensed operators and non-licensed. That would be the Part 15. So it's important, obviously, if you want to use a 5.8 gig system, you need to make sure that everyone's on the same channel number, because if you're not at the same frequency, you're essentially going to say, hey, I'm part of the mesh network, but no one's really going to see me or get to me. So what services are supported? What can I do? Keyboard to keyboard chat, like we were talking about with NWS, like Slack. You can do email with images and attachments. You can do large file transfers. We've all heard of sharing services like OwnCloud. That's one thing you can set up. So kind of like your own personal file sharing. And I'm not talking. Think of peer-to-peer, like back in the day when we would take illegal audio and video, what have you, peer-to-peer. But think of kind of like a sharing service. You can do document sharing, so you could set up a simple transfer there. VoIP phone service, so think of having 4 VoIP phones connected all over PoE, and it's communicating that way over SIP protocol. And then, of course, you could do video conferencing as well. I talked about surveillance cam streaming, so maybe you need a beauty shot of Daily Plaza with whatever emergencies happen. You can do that. You can do computer-aided dispatch. And I'm sure they have that now with public service, but this would be in addition to that. And then, of course, you could do telemetry data from weather stations and sensor monitoring and control with GPIO hats coming from a whole range of Arduino or Raspberry Pis, and then of course GPS tracking. So think of APRS or digital APRS only with this here. Let's talk about the node types. Endpoint, which is a destination, a relay, which could be a repeater, or a backhaul or backbone. Um, those are the three node types. And the installation is pretty easy. Most of us have probably done this with most common switches or routers in our own home, where we download the firmware on the computer, we connect to the dumb switch. In this case, it could be a layer 2 switch. I had one here at one point, but layer 2 switch connected over Ethernet to your node radio, which would be those manufacturers that I mentioned. Don't know what happened there. Oh, well, let me get back. There we go. So the node configuration, as soon as you shoot the firmware on the device, this is what you see. You can give it a node name and a password. And after this one, it kind of gives you the health and welfare and status of your node. And that's what's highlighted here. It gives you, how much your average load is, your network details as far as IP schema, all the good stuff you need. And it even can show you on a pinpoint where you are located on the GPS. So that's the network side. And then the other side actually shows you what's your transmit power rated in dBm, right? It shows you what frequencies are you on. How about channel bandwidth? We've all talked about that. You've heard me talk about that over and over and over again. That really does matter because that also determines, what kind of link quality you have and the files that you can send from point A to point B. At this point, anything that lives on this network is ones and zeros, right? That's how you have to look at it. And then it also shows you the local LAN and how many tunnels can be connected. Local node, this kind of blows it up for you so you can tell what you're looking at there. Ping time, obviously, lower ping time, the better. And what's really cool is this firmware will show you what your processor specs are too. I've worked out a lot of places where your CPU utilization hits like 80 or 90%, and now your network suffers from too much traffic. This is another kind of cool feature. It shows you your neighborhood network. Remember that back on Windows XP in 2000? So this will show you who's in your network and so on and so forth. So I really do like, and I really appreciate how clean the firmware actually runs. And then you can actually check out the entire mesh of all the people that you're connected to. So that's basically an intro to Amateur Radio Emergency Data Network. I've just now found out, and actually Casey's here. Hey, Casey. KV3T. He is, and I'm glad he's here. He's actually, I reached out to Casey and I said, hey man, you guys have had your network on North Shore running for quite some time. And I was hoping if you guys had questions, he's the guy to ask because he actually has implemented it and still runs this literally what I showed you, one of the nodes. So, Casey, you want to introduce yourself real fast?
Yeah, hello everybody. Casey Deers here, KV3T. I'm a member of the North Shore Radio Club. I've also been heading up the effort for the Chicago AREDN network, which is really just a very informal effort to coordinate AREDN efforts in the Chicago area. As you can see on that map, adoption has been glacially slow. I will be upfront that the reason for that is because it needs line of sight, and we all know how hard it is to get tower sites in Chicago. So if you can't see a tower, you likely cannot connect via RF. There is implemented a way around that, which is the use of a tunnel, which is over the internet connecting two nodes together, and then it functions as if it is a perfect RF bridge. And so on that map, any of those light gray dotted lines are tunnels. One other thing I wanted to mention is that there's a concept of a super node, which is a connection to the outside world from a group of RF connected nodes. And so it's just a different type of tunnel. but yeah, we've got several nodes deployed. We have one at Park Tower, which is the North Shore Radio Club repeater site at 520 feet. Um, and several people are connected to that on a regular basis. We also have a PBX set up, so we have several phones connected into that network, and then that is linked to the outside world via that super node to other PBXs around the world. We have some cameras set up and some other things deployed, but yeah, happy to help answer any questions you might have about Arden or our implementation.
Sure. So as far as the tunnel, are you using layer two tunneling protocol? Are you using OpenVPN, WireGuard? What's your usage there?
So, and again, it's not mine, right? I'm
Sure.
just I'm a user just like everybody else. But there is the concept of legacy tunnel, and I'll only mention it because it's being phased out, but you'll still see it about I think it is 30% of tunnels in use today are still the legacy tunnels. That was an open VPN based tunnel system. They have moved to WireGuard now, and that was first introduced about a year and a half ago, and will in 2026 be the only option for a tunnel because it being a mesh, meaning it dynamically regenerates routes based on what is around it. That's a really important part of this because the way that most systems are built out is there is a number of permanent, high quality, sort of class A nodes that are part of the infrastructure. But in an emergency, where you deploy assets is based on the emergency. And so it will automatically find the nearest node to it and connect to that. And the way that it has done that historically is via OLCR, OLSR. I'm user, not designer.
Sure.
But that's switching to a different protocol to regenerate that mesh called Babel. And there is an incompatibility with Babel and the legacy tunnels. And so moving forward, anything that you implement, you should only use WireGuard tunnels. You should only use Babel as the routing. And shortly, that will be the only option.
Okay. We have someone on the call. He shares the same name as me. He lives in Hancock. So um yeah, he's high up. So what's the current coverage of at 520 feet if you had a guess? Line of sight.
So I have an RF dedicated link to Park Tower from my house that's 13 miles.
Okay.
That's a pretty easy connection in terms of distance. The challenge is the trees within a block of my house.
Mhm.
So much better connection in the winter when there's no foliage, almost perfect. This time of year, not so good. It's getting better. Um, Really the distance limitation is going to be just like any other RF. It's obstructions and then the curvature of the earth. Higher's better always. I think things start to get dicey around 40 miles in general. On the Carden website, it's caredn.org. We have a coverage map that is an estimated coverage area, and there's sort of a green and then a yellow. And if you're within that and you have a clear line of sight to that node, you have a pretty good chance of being able to hit it. I will say that being the North Shore Radio Club's repeater site, their primary membership is in the northern suburbs, and so that is a sector antenna pointed north, and so the coverage is much better. It's sort of pointed northwest, and so the coverage to the south, the coverage into Chicago is pretty limited at the moment from that specific node. Um, yeah, always excited to get more people
Oh yeah, yeah.
involved,
That was
especially
sure.
especially coverage in Chicago
Sure.
is very badly needed.
Yeah, we kind of went down this path with Meshtastic, and I bought a 3D printer and I was building all these nodes, and we were hoping to do like a club ordeal there, and it died on the vine. We had several node radios. Um, so correct me if I'm wrong. Does 220 guys and gals have something on top of or near their repeater as well? Are they part of the network?
So they did deploy some equipment. Um, we were not able to coordinate with them, and I'm not sure as of last weekend, I did not see their nodes on the map, so I'm not quite sure what the status of their deployment is.
Okay.
Um, it's decentralized, so anybody can do anything they want anytime.
Right.
I put some effort into coordinating that, and we just weren't able to get coordinated. I was really hoping, we have good line of sight from the park tower to their repeater site, and I was
Mhm.
hoping we could get a backbone link set up there, but it didn't happen.
Yeah.
One other thing I wanted to add on frequencies. So it is true that some of the frequencies are shared with the ISM band where normal Wi-Fi exists. However, AREDN also supports frequencies not in the ISM band, and that's really critical because we have a license for that. And so um, frequencies that are not super congested by your typical Wi-Fi routers. And that also means that the information that you are transferring over AREDN is subject to the limitations of your license. And I won't go into the details because it gets a little bit complicated with encryption. And like, if I sign into a website that has an SSL certificate, am I now doing encrypted over RF? That's something you
Sure.
need to keep in mind. I think that different implementers have different opinions about how that applies to our license, but it is something to keep in mind.
Okay. I'll,
Because at the end of the day, it's a mesh data network. So I have
right.
a 30 megabit connection to that tower that's 13 miles away, and anything I can do on the internet, I can do over that connection.
So one of the questions I have from one of our members is, could you deliver internet over this mesh network?
Yes,
Okay.
absolutely. You can, and it is happens all day, every day.
Okay.
I will tell you, if you try to browse the internet without SSL, you are
Hmm.
going to have a very unpleasant experience. So if you believe that that is in violation of your license, then you may have a challenge doing so. I will tell you that a lot of people have decided that it is acceptable to allow SSL over AREDN, and the project doesn't make a determination on that, right? We're educated users of the
Right.
technology, so it's up to you how you implement that. But I will tell you,
Self-governance. Okay.
if you choose to not utilize SSL, your experience will be very bad. But from a technical standpoint, it's identical to it. And in fact, um, just about any AREDN network that you connect to, you will find an active internet connection. And again, it's mesh, so it'll automatically route traffic to the nearest gateway to you,
Sure.
and then out into the internet.
Okay, so we had a question from Neil. He typed it, with the network moving to nodes that have to support Babel, how do we identify hardware that will be appropriate going forward? Oh, still muted.
Great question. So the AREDN website has a matrix to guide you toward supported hardware.
Hmm.
Um, in general, it is not a hardware limitation to use Babel. It's a software implementation. So I have a bunch of nodes that were previously on the old version, just upgrade to the newest version of software, and now it supports Babel. But in general, for hardware requirements, they have a list of supported hardware on the website, and it really has to be one of those. If it isn't a supported piece of hardware, it's not going to take the firmware.
Okay. Um, what do you think if you were to guess what the average 5 gig budget build would be to get up and running? If you had to guess, what would you say?
So that's really hard
Mhm,
because there's a wide range. I mean, you can get on AREDN for $30 with a
mhm.
little piece of hardware that's this big and sits on your tabletop, and that's not going to do a 12-mile connection.
Right.
So once you get to the range of like a Ubiquiti commercial sector antenna, that's going to be like $250. The
Mhm.
radio's probably $150, I would guess, and then you're going to have some cable and some other things to go between it, and that's sort of a top end spec. I wrote a proposal for a water tower that had 4 nodes on it, one covering each of the 4 cardinal directions off of the water tower, and it was about $1,000. But if you're at home and you're trying to connect to an existing node that's out there, you could probably go on eBay and get some, waterproof equipment and get up on the air in under $100.
Sure. Someone else asked, do we have a parallel digital test with the regular marathon VHF and UHF amateur radio comms? Um,
So marathon, the Chicago Marathon.
I believe so.
So Arden has been discussed for use at the Chicago Marathon for a number of years. The reason that it has not to date is because the marathon's IT team is very nervous about the usage of adjacent spectrum, and that has been a just no reason to argue with them about that. The reality is there probably wouldn't be interference. Rob Orr was the president of the North Shore Radio Club for about 1 million years.
Mhm.
I know him well. We've discussed it. The resources are available to him whenever he wants them, but it hasn't. Haven't had a need sufficient enough to deploy it. And given that there was some pushback from the IT team, they just weren't interested in asking twice.
Excellent. All right. Thanks, Rick, for that question. All right. Anyone
There have
else?
been
Oh, go
there
ahead.
have been there have been deployments for similar activities, and one that I thought was really interesting was it was a group. I can't remember where it was, but it was a similar type of event. What they did is they put little nodes and they zip tied them to light poles with a
Mhm.
battery, and they put a camera on the light pole, and so they had real time camera over Arden using no internet. So if all the power went out, these things would still work and they'd still have this connection. And I think that example really strikes me because it's an example of how flexible this is. You
Sure.
can do almost anything over it, and you can be completely independent from any other infrastructure. And that's why it's so well suited for emergency management.
Let's open the floor to any other questions.
I have one. As far as deploying, if like for example, I have a tower, that's how would I get stuff? How would I deploy it, um, in the air? I, I'm, I'm, I can see a normal, amateur radio antenna, but the Arden, I believe they require power going up to the antenna itself using what bias T, or something. Um, how would that be deployed?
Yeah, so it's actually pretty similar to how you would deploy any other ham radio. There's going to be an antenna component, there's going to be a radio component, and you have to get power to the radio and then the RF to and from the radio to and from the antenna. One thing that's different is given that we're in the gigahertz spectrum, the loss is very high on feed line. And so almost always the radio is deployed at the antenna, if not integral to the antenna. There's a number of nodes that have the antenna and the radio built into one device. So typically you're going to mount an antenna, you're going to attach the radio right onto the back of it, and then there's tiny little cables that connect the two together. And then you almost always you're just running PoE up to the node. And that standalone, no data through the Ethernet cable, that could be a node because that can connect to other devices via RF and get itself on the network. Now, oftentimes that Ethernet cable will go to another node pointed in the other direction, in which case you have a linked connection. Or you may have a computer on the other end of that Ethernet that allows a user a terminal into the network that allows you access to resources on the network.
Okay, that sounds interesting.
How many
Uh,
people know what PoE is? Okay. Power over Ethernet.
So yeah, it's a standard, meaning there's a published standard that all the vendors adhere to about how to deploy hardware in a way that it allows you to transfer power over the Ethernet cable. So an access point, a wireless access point for a Wi-Fi system. Nowadays in a commercial building, there's often the device on the ceiling and there's only one wire going to it. And that's doing both the Ethernet data as well as the power. And it is up to 57 volts, but a lot of these nodes operate on 24 volts DC. So if you're battery powering it, you can a lot of times just run 24 volts DC via a pair of wires, between your battery and your node, and you can go that route as well.
I do have another question. Wasn't if I remember correctly, wasn't there another type of service for like ham radio Wi-Fi or something like that before AREDN?
Yeah, so the broadband ham net, BBHN, that was this was like 2010 era, I would say, on the DDWRT devices and using the same OpenWRT firmware, which actually the AREDN still does. That's you'll notice a great overlap between the OpenWRT firmware support and the AREDN firmware support. But that was the precursor to it, and the reason that it sort of rebranded was because that group was very dedicated to supporting the legacy hardware, and it was limiting the capabilities due to processor power and RAM capabilities. I think they had 8 megs of RAM, and they were just not able to run any services on the nodes. As an example, if you deploy a node now and click yes to all the things, it'll automatically support diagnostic reporting. It'll let you do ping tests. It'll let you do speed tests between nodes. You can install a chat relay server, so it'll store and forward messages to other nodes. And they were not able to do that with the very, very old devices. And so they sort of split ways. And I don't believe the BBHN is around anymore. So this AREDN kind of won the popular vote of which one would move forward.
Yeah, I thought it was something like that, but I couldn't remember what it was.
Yeah, and also in terms of in your presentation, Nate, you mentioned that it's a fairly mature thing at this point. As of a few days ago, there's 2,800 nodes deployed worldwide. They're deployed on every continent except for Antarctica. They're in use every day. They're not being used for a lot because on the whole, they're waiting for an emergency, but they were very instrumental in natural disasters in Florida and Puerto Rico. California uses them to monitor wildfires regularly. It's getting a lot of active use all over the world. It's not getting a lot of active use in Chicago. I welcome anybody that wants to deploy some hardware. And to that end, I have a number of devices in my basement that are some owned by me, some owned by the North Shore Radio Club, that are available for emergency deployment, for supporting IMCOM things, for demonstrations, to help people deploy new hardware. So if there's a need for any of that, feel free to reach out.
So it would be a Go kit.
Yeah, there's two. Okay. So there's a couple of different types of devices. One of them is like a dedicated relay. So the way that most people recommend, and the way that the Chicago deployment has thus far been deployed, is that 5 gig is used for the point-to-point, the A-class signals. Is 2.4 for local. And so we have a dedicated relay node that's intended to connect to a backbone on 5 gig and then rebroadcast that traffic out on 2.4.
Okay.
And then we have a couple of other, one with a camera on it and one with some computer capabilities, and then a bunch of little ones.
So my question for VoIP service, are they using 3CX, or what are they, asterisks? What are they using for that?
Is Open PBX a thing?
I believe it is.
That seems to strike
okay.
a chord with me. I did a little bit of research into PBXs, and then I turned around and walked the other direction because it is so incredibly complicated.
Yeah.
The gentleman that manages it, I'm sure, could tell you more about that.
Okay. Yeah.
It works. They gave me the information. I typed it in. It works.
Yeah, and you know, my goal of having Casey here is not one club versus the other. My goal was to get the masterminds of this technology and bring everyone together and see if we could do a co-op between multiple clubs. And you know, I would include, look at Blue Island, right? Down there with stars. I mean, if we could get a club that's geographically located on a building that we could create um, this technology and then they could all coexist, we could help grow the network. And I think that was my original idea with trying to pick something, um, a topic like this was try to get multiple people from multiple clubs to come join us and kind of discuss here are the benefits, here's what it costs, but also it works, right? So
Yeah, and the deployment that's up is there is a node that is funded by the North Shore Radio Club, but it's not a North Shore Radio Club effort.
right.
The goal is to deploy nodes across Chicago, and anybody that wants to do that, I definitely want to be coordinating with.
Absolutely. We had another question from Neil. If someone is not near the north side of Chicago or near the north suburbs, where is their existing infrastructure and how would they connect to anyone else?
Yeah, absolutely. So the first thing to do is take a look at the map, which is there's a link to it on the AREDN website. It shows all the nodes and when they last checked in. I think they time out after a day or two, so it's always pretty accurate. And if there's not a node that you think you can make an RF link to, then you're looking at tunnels. And um, all new, so they call them mesh islands, the groups of nodes that are together that have RF connection to one another. And all the RF mesh islands started as a single node tunneled into a different node. And that's how you build out a local implementation of AREDN is you put some nodes there and then eventually, get it high enough that your neighbors can connect to it and then hopefully get a backbone link to another RF site. If not, that's fine. You're your own mesh island, link to other nodes over the internet.
So the internet could essentially be the backbone in the beginning, to
Absolutely.
connect multiple people.
Absolutely. It's best to avoid that whenever you can,
Mhm.
because the point of it is an emergency network, and we all assume the internet's going to go down in an emergency. And that's where the idea of a super node comes in, which is what links mesh islands together.
Mhm.
The idea is that services that you deploy for use in local emergencies all of those services will remain active if the internet is gone. That's the goal. But for the purposes of building it out, there's no reason not to use the internet. It's a great resource. And it helps people learn about the technology, figure out if it's something you want to get more into. So yeah, absolutely.
Great question. I
Uh,
did
I
paste that link, by the way. Go ahead, Mark.
Oh, okay. I kind of have two questions. I don't know about the second one, but what do you guys use PBX for in your North Shore thing? And the second, if I can get personal, do you live in your mother's basement?
So we don't use the PBX for anything. It's there and available to use. The reason that the PBX is really useful is in an emergency scenario, it's really easy to hand a phone to somebody that doesn't know how to use a radio and they can communicate very easily out. The implementation that we have is not very useful for anything because the only people that I can call currently are people that are connected to AREDN, which is very few. But the idea of having a PBX is developing out capabilities that can be used moving forward. And do I live in my mother's basement? I don't. I'm at work right now in a cubicle so that I can take this phone call and not disturb anybody in my office.
Which we thank you for being here. I know you and I emailed back and forth. So
yeah, no problem.
And in a full disclosure, I met Casey after I left the FM club field day, and I went to, obviously everyone knows I have a friend up there that does Motorola work for me with all the radios by. I'm like, well, damn, there's the library I stopped in. That's where I met Casey back during field day. So that's the connection here. And like I said, thank you, Casey, for being here because I know that you have firsthand experience with this. And we don't always have that opportunity with these lunch and learns. So.
Yeah, no problem. I'm glad to get more people excited about using it.
And like I said, if someone knows of a high spot somewhere on a roof that's 50 floors up or what, I mean, if there's an idea that you have to help us grow this, please let us know.
Absolutely.
everyone knows that I work pretty closely with Rob, and WBBM has hosted a repeater twice now
Mhm.
for these events. And for the half marathon, our friends at WLS, I grabbed his shit, took it up to floor 100 in their transmitter suite. I don't work at WLS, but they were kind enough to host our backup repeater. So um, most important thing is don't be afraid to ask. Um,
Absolutely. And just to say that exact same thing in a different way, I don't want to host gear on your site. I want you to host gear on your site, and I will gladly train you how to do that. I will happily answer any questions I can or get you in touch with a person that can answer the questions, and we can coordinate on getting them connected. But it's intentionally decentralized, and that's how the implementation should go too. The person with the interest should get coordinated with an existing setup, be it over the internet or via RF, and build it out from there. And what you can do anything with it, you have to decide what you want to do with it. The entire program is sort of slated towards IMCOM, but it's also very useful for other things. In Southern California, they do like Zoom nets over AREDN, over RF. They're using voice and video chat, which is pretty cool.
Yeah, and I will say this, since I've started these lunch and learns, if there's a person that you know that couldn't make it to this meeting, send them the recording. I'll put it on YouTube. And same thing with you, Casey. Anyone that you know, because I have one person in the club, won't say who, they go FM club, they go, well, how the hell can you send internet over that? Well, we talked about that now, didn't we? So that kind of helps the naysayers. So we would never use this. Well, no, and here's the use case. But I feel like this is kind of Meshtastic on steroids. Meshtastic has really, really grown in the last 2 years, but what are we using it for? Sending text messages. That's it. Like, yeah, there's no excitement there. But with this, the possibilities are endless. You can really do a lot with ones and zeros and data and how we implement it. So, all right, we're hitting the.
I have another question, if
Oh, go ahead.
possible.
Sure.
Um, Real quick, what is the data usage as far as like, let's say if I have a site that does not have internet or does have internet, but they won't allow me to utilize their internet. I need to use let's say a cell phone plan or something like that. What is the data usage monthly? Does anybody
So
know?
it depends a lot. It depends a lot on the concept of a mesh island, which is everything connected via RF. Each of those devices check in to each other device periodically. I don't know the details, but they do that because they check the route, the link distance, it's called, to see how good of the connection they have to each other node. And then they use that to recalculate the mesh. Um, in a scenario like you describe, you could just turn off the internet. Just don't have it connected to the internet and either utilize the internet connection from a node that you are connected to via RF or only utilize services that are available on the network. So part of the idea of the super node is that that node by definition has to have an internet connection. All of the other nodes can either choose to have an internet connection or not. And by that, I mean, there's a checkbox that says allow mesh users the use of my internet connection. If you uncheck that, you will have no internet. You will have no connection to the outside world from the mesh. You can still connect into that. Let's say you tunnel into that on the network side, you can still remotely access it. You're just not allowing traffic that came in off of the mesh network, off of the mesh island to communicate beyond your node.
Okay, that sounds interesting. 'Cause the reason why is because one of my friends, he had a repeater, and I tried to get him to link the repeater up to Echo Link for the longest time, and he's like, I don't have access to their internet, and I tried to try to do something with like with a cell phone network, and he was interested in it, but didn't want to fork out the bill for data, so
Yeah, the Park Tower deployment has an internet connection, and it is managed by the North Shore Radio Club, and they don't want random strangers using their internet connection. Totally reasonable. However, there is an active tunnel connection to that device over that internet connection. So we have internet turned off. The tunnel still works, but there's no traffic going back and forth other than the tunnel traffic.
Okay, that would probably work. Could you with this? I'm pretty sure you probably could, but it could. Well, yeah, you could. Never mind. Question already answered
Yeah.
myself.
Another example is if you have a tower site where you don't have an internet connection, but let's say across the street you have a fiber internet connection. You just put another node down there on the same frequencies, and then that's where your network comes from.
I was actually thinking about putting like if said said repeater didn't have internet, you did link it. Could you link up like a normal RF to the node and then or the mesh and then have it go to another out to the internet for like
Yeah.
yeah. Okay, yeah,
Absolutely.
I thought of it and it was like, all right, yeah, we could do that.
One thing to keep in mind is that every additional link adds latency. And so just like Wi-Fi adds latency, that can there's a technical term for it, I don't remember what it is, but it the more jumps you have between you and a low latency connection, the more hops you have, the higher latency you're going to have. So you'd want to do some testing to make sure the quality was sufficient, but it's definitely possible.
And that's where your ping time comes in too.
Exactly. And it changes too, right? It may be that today you have a low RO, there's a crane in the way or something, and so you'll still have a connection, but the ping will be way different, and then it changes again. So
good questions.
Yeah.
Good questions. Before we wrap, Rick had one more question. Is the reason that no wavelengths decametric wavelength is in use due to the fact of limited bandwidth? So you're using 10 megahertz as far as channel bandwidth. So
I have not yet seen a use case that we could not do because we were limited by bandwidth. I think the theoretical limit is like 130 or 40 megabits a second, and that's really fast over RF. My connection, my 13-mile connection, can regularly do 20 or 30, and that's I don't know what that is in baud, but it's a lot of data.
Right. Yeah. 9600.
If decametric is some sort of spread spectrum or other more technical thing, I don't know what that means, so I can't answer your question. I'm sure there's somebody on the AREDN development team that can, though.
All right. Well, any other last questions before we tie this one up? We're almost about to hit the 1 hour mark. Sweet. Well, thanks for being here, Casey. Thanks everyone for being here. Like I said, share this with your friends. As soon as we're done here, the recording will be online. If you have any more questions, you can definitely look up Casey's QRZ information if he's willing to answer. I know you're a busy guy, but
I'm easy to find.
Yeah. So, like I said, I met Casey. I was like, "Damn, this is really cool. If we can pick his brain on how it works, and we already know why, obviously. This is some good stuff." So once again, I want to thank everyone for being here. Next Wednesday, same time, and I'll send out a note on what that topic is. So thanks everyone for being here. Have a great day. Thanks, Casey.
Thank you all. Thank you, Nate.
You bet. Thanks.
Thanks for the reminder too.
Oh, absolutely. Good to see you around.
Dan, you're doing these every week?
Yes. Yep.
Oh man, you're tired.
No, well, I mean, I'm tired because I got up at 3 a.m. BPM keeps me busy. I've already worked 8 hours, man. So, I usually hit about 5 o'clock and I'm like, boom. But no, between where our stuff is and North, I think there's a lot of possibilities there. It's just,
Absolutely.
yeah, like I said, I think it's